Hello guys, here Mr. G with another video. This time it's going to be a video for the grade 11. It is going to be related to Newton's law. It's also applicable for the grade 12. This was a question 3 from June 2023 done in the Northern Cape province, so it can help the children from other provinces who didn't write the question paper yet. This question said a 10 kilogram block is at rest. Remember, rest means that the velocity is 0 on a rough inclined plane, making an angle of 30 degrees with a horizontal as shown in the diagram below. The coefficient of static friction between the inclined plane and the 10 kilogram block is 0.6, as you can see there. Then question 3.1 define the term normal force. It's just a definition and we are going to start with that one real fast. Okay, so what is normal force? It's the perpendicular force a surface exerts on an object that is in contact with the surface. I mark here the word perpendicular because you need to know that the normal force is always going to be perpendicular to the surface. Question 3.2, calculate the magnitude of the normal force on the object. But before we doing that, we're going to draw the free body diagram on this object here. And for this one, I am going to add the axis because I always like to add the axis to help us here. Now, what forces are acting on that block? There is the normal, which is always perpendicular to the x-axis. Remember, to the surface, and the x-axis here represent the surface. So this one here is the normal force. What other forces acting there? There is frictional force. In this case, it's going to be the static frictional force, because the object is not moving. And finally, we have the weight or gravitational force, which is going to be pointing straight down towards the center of the earth. Now, here, remember that this is in none of the axes, so I must project that force to each axis here, and I will have weight in the x-axis there, and here in the y I will have weight in the y-axis. And I also want you to remember that the angle of inclination, this 30 degree, which is in this case here, this 30 degree will be this angle here. That one there will also be 30 degrees. So saying that this angle here corresponds to the angle of inclination of the inclined plane. So if you, for instance, want to calculate the weight in the x-axis, you can see that it's opposite side to the angle and is equal then to weight multiplied by the sine of theta, which in this case is 30 degree. And if you substitute theta, it's going to be mass multiplied by acceleration times gravity multiplied by the sine of 30 degree. And if you want to calculate the weight in the y-axis, is equal to weight adjacent side, so it's going to be cosine of 30 degrees. And if you substitute here the value of a of weight, is going to be mass acceleration due to gravity multiplied by the cosine of theta, which in this case is 30 degrees. So this one is something to you or for you to remember. Okay, so now we're looking for the normal, and you need to know that the normal is in the y-axis. So we are going to work in the y-axis. So we are going to solve that question on this side. This one is question 3.2.1. Okay, 3.2.1. We're looking for the normal force. Now, I am going to apply Newton's first law. F net is equal to 0 because the object is not moving. When the object is not moving, you apply Newton's first law. If you go to the y-axis, and I'm going to write here in y-axis. Now, know the following, I'm solving this one as a teacher, so I'm explaining everything. You don't have to do or write everything I write here, guys. Okay, you just have to do the substitutions and so on. So here in the y-axis, we have the normal minus weight in the y-axis is equal to 0. And if you rearrange this one, you get that the normal is equal to weight in the y-axis, and if we substitute the formulas here, you get that is equal to mg multiplied by the cosine of 30 degrees. So normal is equal to, now you can substitute everything because you have all the numerical values here. So it's 10 multiplied by 9,8 multiplied by the cosine of 30 degrees, and then the normal is going to be equal to, and then the answer is going to be 84,87. This one is the normal force, 84,87 Newton, that is the unit, and it's very important. Now, question 3.2.2, there is a problem here with the numbering. That is not a big problem, guys. Calculate the maximum static frictional force acting on the object. Now, to calculate the maximum static frictional force, before we do the calculation, I want you to go to the formulas. And here is the formula for the maximum static frictional force. On this side here, you can see it. That is the formula to calculate the maximum static frictional force. So it's the product of static coefficient of friction and normal force. So we are going to do that one right here at the bottom there. This one is question 3.2.2. Okay, now calculate the maximum static frictional force. The formula for that one is this one. You did see the formulas there. It's equal to static coefficient of friction, which is given to us, multiplied by the normal, which you just calculated. So when you substitute the static coefficient of friction, guys, here 0.60, so is 0.60 multiply, you cannot write the 0 if you don't want, you don't have to, multiply by the normal, which it did calculate, and is 84,87. 84,87. And when you do this calculation, you get that the final answer is 50,92 Newton, and this is the answer for the maximum static frictional force. So that is question 3.2.2. Question 3.3. With a suitable calculation, explain why the object is at rest. Now this question is a little bit tricky and it's some issues here, guys. Now what we need to know, if the object is at rest, is because the forces are at equilibrium. This one is Newton's first law. So if the object is at rest, it means because the forces that is acting on the object in the x direction down must be equal to the forces that is in the x direction up. In other words, the forces here must be parallel pointing down, must be equal to the forces parallel pointing up there, because the object is at equilibrium. So all we have to do, we want to work in the x-axis, and here in the x-axis, here we have the static frictional force and we have the weight in x. We do have the value of the weight in x, but we do not have the value of the gravitational force in x. We have only the maximum static frictional force. So we're going to solve this question here, 3.3, and we are going to calculate the weight in the x-axis. Remember, that one is equal to weight multiplied by sine theta. We see it here in the free body diagram. So now in this case here, guys, we have that the weight in x is equal to mass multiplied by acceleration due to gravity multiplied by the sine of theta, which is 30 degrees. When you substitute, because you have all the values here, this one is equal to 10 multiplied by 9,8 multiplied by sin 30 degrees. And when you calculate that one, you get that the answer is 49 Newton. This one is the weight in x. Now, if you go back here, this force is a 49 Newton, but the maximum static frictional force was 50,92. So you can see that the maximum static frictional force is bigger than the weight in the x-axis. That is the reason because the object is at rest, or why is the object at rest. So the first thing we have to say is that the weight in x is smaller than the maximum static frictional force, and that is why this object is not sliding down. So this is the reason, but you have to calculate, like they say, use a calculation. Question 3.4, how will the coefficient of friction change if the angle of the incline above change to 45? Guys, in this case it remain the same. It remain the same, because the coefficient of friction does not depend on the angle. The coefficient of friction depends on the type of material. The coefficient of static friction only depends on the type of material or substance. Guys, this is question 3. I hope it helped. It's a quite simple question. Thank you for watching. Subscribe for the channel, thumb up. I'll see you next time. Mr. G here.